As I'm sure you're aware, a table is one way to organize data so that you can understand the meaning and recognize any relationships. The exercise here is to make a table given the data that's in here. This is kind of wordy. Jack timed his bus rides to and from school. On Monday, it took 7 minutes to get to school and 9 minutes to get home. On Tuesday, it took 5 minutes and 9 minutes, respectively. And on Wednesday, it took 8 minutes and 7 minutes. You can see that that's not a great way to represent those numbers, but a table would be better. Notice that it is organized. The order makes sense. We've got Monday, Tuesday, and Wednesday, to school and to home. So we've got proper headings. Everything's very nicely organized. Here we've got some other data that we're going to put into a table. Same idea, good organization, easy to look at, easy to comprehend. Okay, now we're going to move on to this crazy stem and leaf plot. I don't love stem and leaf plots, but they show up on tests all over the place, so you need to know about it. A stem and leaf plot is another way to display data. The values are grouped so that all but the last digit is the same in each category. Okay, so each piece of data is represented like this. This is the stem, this is the leaf, and this right here means 25. Okay, so they want you to list the values that are in this stem and leaf plot. So here they are. And it's always good to have a key so that a person could figure out what it is you're representing there if they're not familiar with stem and leaf plots. Okay, so down here at the bottom we have all of the numbers that are represented in the stem and leaf plot. This makes 12. This with this makes 15. And then we've got 40 and 41. Notice if a number comes up twice in your data set, then it appears twice in your stem and leaf plot as well. Then we've got 52, 57, and 59. So that's a stem and leaf plot to represent this data. Here's another stem and leaf plot, and you have to be able to get these numbers out of this stem and leaf plot, and I think that's pretty self-explanatory. Notice that these things do go in order, so really the first thing you want to do with your data set is put the items in order so that they're easier to put on the stem and leaf plot, and again some kind of a key. So then of course you're going to have to know how to actually create a stem and leaf plot as well. So here you've got your data set. Notice that they were kind enough to put the numbers in order for you. So you're going to want to look at the tens place here, and you can see that they go from 40s to 50s to 60s. So we've got 40s, 50s, and 60s here, and then the ones place for each item in your data set. Would have been good to have had some sort of a key, such as this. Alright, we're going to make a stem and leaf plot for this data set. You can see almost all of the numbers are in the 20s, but we've got one in the 30s. So our stems are going to be 2 and 3. And then we go ahead and add the ones place for each one of those pieces of data and give a key. And that's all there is to it. Okay, then we've got this back-to-back stem and leaf plot. This confuses people sometimes. It's used to compare two sets of data. The stems are in the center, and the left leaves are read in reverse. All right, so we kind of have two sets of data here. We've got 1950 data and 2000 data. What's it mean here? U.S. representatives for selected states in 1950 and in 2000, okay? So We're going to make a back-to-back stem and leaf plot to represent this data. And this is what it looks like. Okay, so as we look at everything we've got here, the low number is 10, and that's got a 1 in the tens place, so that's where we're going to get this 1. And then we've got some things in the 20s, 30s, and 40s, so that's where we're getting all of these stems. Okay, then we go ahead and plot each item. The 1950 items are all over here, and you should be able to find all of them. We've got 18, 14, 25, 31, 43. See what they mean? What they meant when they said the left ones are read in reverse. Okay, and then the ones over here are just like the regular stem and leaf plot that you've got 10, 15, 19, 19, 29, and then that 2000 data doesn't have anything in the 30s or the 40s. So that's a back-to-back stem and leaf plot. Notice two parts to the key, that this means 29, and this means 18, which is a little bit confusing. We're supposed to make a double stem or a back-to-back stem and leaf plot for this information. First, you always want to wrap your brain around what is this table or what is this data about. So we've got voting statistics and the ages of eligible voters and how many voted versus how many did not vote. Notice that this is in millions, which makes a huge difference, but we're just going to plot it with these lower numbers, and then we'll note that it's in millions. Okay, so that's how we set it up. We've got our little column down the middle, and then let's go ahead and find our tens places and see we've got some single digit numbers here. So the tens place is going to be 0, and then our high number looks like it's about 24. So we're going to have 0, 1, and 2 for our stems. And then we've got our did not vote over here and our voted over here. This is 5, 5, 8. Then we've got 14, 18, 20, and 21 over here. So remember, that has to be read backwards. They did not put any kind of a key in here. You can pick any numbers you want. Let's say 5, 0, that equals 5. And then the other way, we've got 1, 0 equals 10. And we should also really have, it'd be good if they had some kind of a title, voting statistics. And then I'd put in millions, because that's pretty important to note. Okay, if you want to try out making a table, why don't you go ahead and finish filling that in, pause it, and then come back for your answers. And then list all of the data values for this stem and leaf plot, pause it, and come back to check.